Thousands of years ago, under a sky unpolluted by city lights, our ancestors gazed up at the same stars we see today, but their understanding of the cosmos was worlds apart from ours. Without telescopes or satellites, they wove intricate stories of gods and monsters among the stars, turning the heavens into a canvas for myth and meaning. Yet hidden within those ancient tales was something astonishing: the beginnings of scientific observation. From the Babylonians meticulously recording planetary movements to the Mayans constructing pyramids that aligned with celestial events, these civilizations didn't just worship the stars, they studied them. What if I told you that the line between ancient astronomy and modern science is far thinner than we often assume? Picture this: a Babylonian scribe etching symbols into clay tablets under the glow of a crescent moon, tracking Venus's path with startling precision. Or an Egyptian priest aligning the Great Pyramid so precisely that its sides face the cardinal directions, a feat that still baffles engineers today. These weren't just acts of devotion, they were early experiments in understanding the universe. The cosmos was a sacred text to be decoded, a divine mystery intertwined with the rhythms of daily life. Seasons were predicted, calendars were born, and entire cultures shaped their identities around the movements of the heavens. But how did these ancient stargazers reconcile the spiritual with the scientific? And what can their discoveries teach us about our own place in the universe? This is a journey into the minds of those who first dared to map the sky. We'll unravel how the stars served as both clock and compass, guiding sailors across oceans and farmers through planting seasons. We'll explore how celestial events like eclipses were seen as omens, sparking both fear and fascination. And we'll discover how these early interpretations, part poetry, part precision, laid the groundwork for the astronomy we know today. By the end, you'll see the night sky not just as a collection of distant lights, but as a living archive of human curiosity. So let's step back in time to an era when the cosmos was a story waiting to be told, one that still echoes in our quest to understand the universe. Long before cities carved their silhouettes against the horizon, before the written word captured human thought, our ancestors tilted their heads back and saw more than just scattered lights. They saw a story. The night sky was humanity's first library, its constellations acting as both calendar and scripture. For early civilizations, the heavens weren't distant specks of light, but a living, breathing entity intimately tied to survival. Picture a Neolithic farmer in Mesopotamia scanning the horizon for the rise of Sirius, knowing its appearance signaled the annual flooding of the Nile, a natural alarm clock dictating when to plant crops. Or imagine Polynesian navigators reading star paths like road maps, their canoes guided by the shimmering trails of the Milky Way. What's fascinating is how these early sky watchers didn't separate science from spirituality. To them, the cosmos was a conversation. The Babylonians, for instance, tracked Jupiter's motion not just to predict seasons, but to discern the will of their god Marduk. In China, court astronomers recorded guest stars, what we now call supernova, as celestial omens, their observations so meticulous that modern scientists still reference their records. Even Stonehenge, with its towering heel stone aligned to the summer solstice sunrise, reveals a duality of purpose, part temple, part astronomical calculator. This fusion of myth and measurement wasn't primitive guesswork, it was the birth of empirical thinking. Take the Maya, whose Dresden Codex contains tables predicting Venus's cycles with near-modern accuracy. Or consider how Egyptian priests used the star Sopdet our Sirius to recalibrate their solar calendar every year, correcting for Earth's wobble millennia before astronomers understood axial precession. These weren't just rituals, they were repeated experiments, their data etched in stone and bone. Yet the most profound insight lies in what these cultures shared, an understanding that the cosmos shaped human destiny. When an eclipse darkened the sky, Aztec priests sounded conch shells to feed the sun, believing it under attack. Norse myths wove the auroras into tales of Valkyrie's armor, while Aboriginal Australians saw the emu in the dark, a constellation dictating when to hunt for eggs. Every culture, in its way, was asking the same questions we grapple with today. Why are we here? How does the universe work? Their answers blended poetry with precision, reminding us that science and wonder have always been two sides of the same coin. What emerges from these ancient stargazers isn't just a history of astronomy, but a testament to human ingenuity. Without lenses or satellites, they mapped planetary loops, predicted eclipses, and built structures that still leave us awestruck. Their legacy whispers a truth we often forget. To understand the stars, you must first dare to dream them. In the Fertile Crescent between the Tigris and Euphrates rivers, where writing itself was born, another revolution was taking place, one etched in clay and stars. The Babylonians and Sumerians didn't just watch the sky, they transformed it into humanity's first data set. Imagine a temple scribe in Ur, pressing wedge-shaped marks into a damp tablet, noting Jupiter's retrograde motion with the same precision we'd expect from modern astronomers. These weren't mere observations, they were sacred equations believed to hold messages from the gods. Every planetary loop, every eclipse, was a celestial telegram decoded by priest astronomers who doubled as ancient scientists. What set Mesopotamia apart was their systematic approach. By the 7th century BCE, they'd compiled the Mul-Apin, a star catalogue so detailed it listed rising times for constellations and even accounted for the shifting positions of planets. Their math was revolutionary, using base 60 numerals, the reason we have 60 minutes in an hour. They calculated Venus's 8-year cycle within mere hours of modern measurements. But here's the twist, their science was inseparable from spirituality. A solar eclipse wasn't just an orbital alignment, it signaled potential upheaval for the king, prompting rituals to avert disaster. The brilliance of these sky watchers lay in their dual vision. While tracking lunar phases to build their lunisolar calendar, they also mapped the zodiac, dividing the sky into 12 sections that later shaped Western astrology. Their Enuma Anu Enlil tablets, a collection of 70 celestial omens, read like an ancient almanac. If Mars approaches Scorpio, the king will face rebellion. To modern ears, this blends superstition with science, but their methods were astonishingly empirical. By recording patterns over centuries, they noticed, for instance, that eclipses recurred in 18-year cycles, a discovery now known as the Saros cycle, still used by astronomers today. Their legacy rippled far beyond clay tablets. Greek scholars like Hipparchus later borrowed Babylonian star data, while Islamic astronomers refined their math into trigonometry. Even NASA, a jet propulsion laboratory, used Babylonian eclipse records to study Earth's rotation, changes over millennia. Yet perhaps their greatest gift was a mindset, the conviction that the cosmos operated by rules waiting to be uncovered. Whether interpreting a comet as a divine warning or calculating Jupiter's path with algebraic equations, these ancient stargazers proved that curiosity, whether dressed in priestly robes or lab coats, is timeless. The night sky they studied still arches over us, but their questions echo louder than ever. How do we separate pattern from prophecy? When does observation become understanding? In their cuneiform numbers and star charts, we find the first flickers of a truth that still guides us, that to study the heavens is to search for our own reflection. To the ancient Egyptians, the night sky wasn't just a spectacle, it was a mirror. The Milky Way arched overhead like a celestial twin of the life-giving Nile, its shimmering currents guiding departed souls to the afterlife, much as the river nourished the living. This wasn't mere poetry, it was cosmology written in starlight. Every aspect of their universe intertwined, from the annual flooding of the Nile, triggered by Sirius's first dawn appearance, to the very stones of their pyramids, which pointed toward the heavens with mathematical precision. Consider the Great Pyramid of Giza. Its four sides aligned almost perfectly with the cardinal directions, a feat requiring knowledge of true north that still puzzles historians. But the alignment went deeper. The pyramid's narrow shafts, once thought to be ventilation channels, actually framed key stars, one aimed at Sirius, the brightest star in the sky and the symbol of Isis, while another targeted Orion's belt, associated with Osiris, god of the afterlife. For the Egyptians, these weren't just architectural quirks, they were cosmic gateways. When a pharaoh died, his soul embarked on a celestial journey, sailing the Milky Way's celestial river to join the gods. The pyramids then weren't just tombs, they were launch pads for divinity. The star Sirius held particular power. Its heliacal rising, when it first became visible just before dawn after months of absence, coincided with the Nile's annual inundation, an event so vital it marked the Egyptian New Year. The goddess Sopdet, personified by Sirius, wasn't just a celestial marker, she was the herald of renewal, tying the rhythms of farming to the motions of the cosmos. Priests tracked Sirius's movements with such care that their records, etched on temple walls, reveal a sophisticated understanding of the star's 1461-year cycle, a period now known as the Zodiac cycle. Yet the stars weren't just timekeepers, they were active participants in the afterlife. The Book of the Dead, filled with spells to guide souls, describes the sky as a place where the deceased transformed into stars or joined the sun god Ra in his solar bark. Tomb paintings depict Nut, the sky goddess, swallowing the sun each evening and giving birth to it at dawn, while the decans, 36-star groups, acted as nightly hour markers, dividing darkness into measurable segments. This wasn't just mythology, it was a functional astronomy that shaped daily life, from religious rituals to agricultural planning. What makes Egyptian cosmology so compelling is its seamless blend of utility and wonder. The same priests who used the stars to predict floods also believed the sky was a physical realm where gods and souls interacted. Their temples doubled as observatories, their rituals as scientific experiments. When they aligned a temple to the winter solstice sunrise, they weren't just honoring Ra, they were mapping the universe's order. In their worldview, the divine and the measurable weren't at odds, they were two sides of the same papyrus scroll. Their legacy lingers not just in stone, but in how we still grapple with the night sky's mysteries. The Egyptians remind us that astronomy began not with cold calculation, but with awe, a desire to read the stars as both map and myth. Whether charting Sirius's path or preparing a pharaoh's soul for its celestial voyage, they sought answers to questions we still ask: what lies beyond? How are we connected to the cosmos? Their answer, written in hieroglyphs and stone, whispers across millennia: the sky isn't above us, it's part of us. While the Egyptians aligned their pyramids with the stars halfway across the world, the Maya were perfecting a celestial clockwork so precise it still leaves modern astronomers in awe. For them, time wasn't a straight line, it was a spinning wheel with celestial events recurring in grand, predictable cycles. Their calendar didn't just mark days, it mapped the universe's heartbeat, tracking Venus's 8-year dance across the sky and predicting eclipses centuries in advance with razor-sharp accuracy. At the heart of their cosmic vision stood the Pyramid of Kukulkan at Chichen Itza, a stone testament to their astronomical genius. During the spring and autumn equinoxes, as the sun dipped toward the horizon, its light would cascade down the pyramid's stepped sides, casting a shadow that slithered like a serpent along the staircase. This wasn't accidental artistry. It was celestial engineering, a visual representation of Kukulkan, the feathered serpent god descending to Earth. The pyramid's 91 steps on each of its 4 sides, plus the shared platform at the top, totaled 365, a physical embodiment of their solar year. Every corner of their architecture whispered secrets of the sky, but the Mayas' true brilliance lay in their calendars. While we juggle one calendar today, they synchronized 3, the 260-day sacred Tzolk'in, used for rituals and divination, the 365-day Hob, tracking the solar year, and the long count, a linear tally of days stretching back to a mythical starting point in August of 3114 BCE. Together, these systems formed an interlocking mechanism more intricate than any clock. Their priests could calculate the synodic period of Venus, the time it takes to return to the same point in the sky down to a margin of error of just 2 hours per 500 years. What's even more astonishing is how they wove astronomy into daily life. Eclipses weren't just celestial events, they were omens of upheaval, prompting rulers to perform bloodletting rituals to feed the gods and maintain cosmic balance. The Dresden Codex, one of the few surviving Maya books, contains tables predicting solar eclipses and Venus's movements with mathematical precision. Their observations were so meticulous that modern researchers have used their records to correct orbital calculations for Earth's moon. Yet the Mayas' greatest insight was their view of time as a spiral, a series of repeating patterns where history didn't just rhyme but repeated. Their calendar round cycled every 52 years, a period seen as a cosmic renewal where the world risked destruction if rituals failed. This cyclical thinking extended to their mythos, where creation wasn't a one-time event but a process that had unfolded and collapsed multiple times before. Their legacy challenges our modern divide between science and spirituality. When a Maya astronomer priest tracked Mars's retrograde motion, he wasn't just collecting data, he was decoding the will of the gods. Their celestial observations, etched into stelae and codices, reveal a culture that saw no contradiction between precise mathematics and divine prophecy. In their world, the heavens were both clock and scripture, and to study them was to participate in a sacred dialogue with time itself. Today, as we peer into space with telescopes and satellites, the Maya remind us that astronomy has always been more than cold calculation. It's the story of how humans find meaning in the stars. Their pyramids still stand, their calendars still whisper, and their vision of a cyclical cosmos feels strangely resonant in an age where we're just beginning to grasp the universe's vast, repeating patterns. While the Maya tracked Venus with mathematical precision and the Egyptians aligned pyramids with star shafts, the ancient Greeks were asking a revolutionary question: what if the cosmos wasn't just governed by gods but by geometry? Picture Pythagoras standing on a moonlit beach in 6th century BC Samos, tracing shapes in the sand as waves lapped at his feet. To him, the universe wasn't a chaotic realm of capricious deities, it was a symphony of numbers. His followers believed celestial bodies moved in harmony with the music of the spheres, an idea blending mysticism with an early grasp of orbital mechanics. This was the turning point where stargazing evolved from interpreting omens to uncovering universal laws. Plato's Academy took this further, teaching that planets moved in perfect, unvarying circles, a reflection of his belief in an ideal realm beyond the flawed physical world. His student Eudoxus devised the first geometric model of the cosmos, nesting 27 rotating spheres to explain planetary motions. Though flawed, it was a staggering leap, an attempt to map the heavens using pure mathematics rather than mythology. Then came Aristarchus of Samos, a mind centuries ahead of his time. While most Greeks placed Earth at the universe's center, he argued the sun held that position with planets circling it. His heliocentric model, proposed in the 3rd century BCE, wouldn't be widely accepted for another 1800 years until a certain Polish astronomer named Copernicus revived it. Yet Greek astronomy never fully abandoned the divine. Aristotle, while systematizing the natural world, still saw the stars as made of an unchanging fifth element beyond earthly corruption. His cosmic model, Earth-centered with nested crystalline spheres, dominated Western thought for 2 millennia. Even Hipparchus, who calculated the Earth's precession with stunning accuracy, saw celestial events as potential omens. What made the Greeks unique was their dual lens. They sought rational explanations without dismissing the sacred. The Delphic maxim, "Know thyself," extended to the heavens. Understanding the cosmos was a path to understanding humanity's place within it. Their tools were as ingenious as their theories. The Antikythera Mechanism, recovered from a shipwreck in 1901, reveals their technical prowess, a bronze computer with interlocking gears that predicted eclipses and tracked Olympic cycles. Devices like this weren't just scientific instruments, they were philosophical statements proving the universe operated by discernible rules. The Greek legacy lies in their fearless questioning. Where earlier cultures saw gods steering the stars, they sought geometric patterns. Where priests read omens, mathematicians calculated orbits, yet their science remained tinged with wonder, a reminder that peeling back the universe's layers doesn't diminish its mystery but deepens it. In their hands, astronomy stopped being just about divining the future and started becoming about discovering truth. In the courts of ancient China, the night sky was more than a spectacle. It was a celestial bureaucracy mirroring the imperial court below. When a comet streaked across the heavens or the moon swallowed the sun, these weren't just natural phenomena. They were urgent memos from the cosmos, scrutinized by court astronomers whose observations could alter the fate of dynasties. The Chinese called it Tiananmen, the mandate of heaven, a divine contract where an emperor's right to rule depended on maintaining harmony between earth and sky. A single eclipse could topple thrones, while a supernova might herald rebellion, making astronomers the most powerful advisors in the Forbidden City. The precision of their record still stuns modern scientists. Take the guest star of 1054 CE, documented by Song Dynasty astronomers as appearing near the constellation Taurus. What they described, a star bright enough to be visible for 23 days even in daylight, was actually the Crab Nebula supernova, whose remnants we still study today. Their logs, etched on oracle bones and silk scrolls, contain the world's first documented sunspot observations from 28 BCE, centuries before Galileo turned his telescope skyward. But these weren't neutral scientific notes. Each entry carried political weight. When a broom star, their term for comets, appeared, it signaled heaven's displeasure, often prompting emperors to issue public apologies or dismiss corrupt officials to restore cosmic balance. Astronomy was so vital that the Imperial Observatory became a state secret, its instruments guarded like treasure. The armillary sphere, a bronze masterpiece of interlocking rings, mapped celestial movements with breathtaking accuracy, while the gnomon, a towering sundial, marked solstices to regulate the agricultural calendar. Emperors like Kangxi of the Qing dynasty studied astronomy personally, knowing that interpreting heavenly signs was key to quelling unrest. In 1660, when Jesuit missionary Ferdinand Verbiest corrected the imperial calendar's errors, it wasn't just a scientific triumph, it reinforced the emperor's divine legitimacy by proving he could read heaven's will correctly. The most dramatic example unfolded in 2134 BCE during the legendary Xia dynasty. When astronomers failed to predict a total solar eclipse, chronicles claim the emperor panicked, ordering drums beaten and arrows fired skyward to scare off the dragon devouring the sun. Though likely myth, the story reveals a profound truth. In China, astronomy was never detached from human affairs. Even the layout of Beijing mirrored the heavens, with the Forbidden City's central axis aligned to Polaris, the great imperial pole star, around which all other stars obediently revolved, a cosmic metaphor for imperial authority. What set Chinese astronomy apart was its uninterrupted continuity. While other civilizations' knowledge faded or fractured, China's star catalogue spanned millennia, creating a data goldmine modern astrophysicists use to study stellar evolution. Yet their legacy isn't just in records but in philosophy, the idea that humanity isn't separate from the cosmos but accountable to it. When a Ming dynasty astronomer inscribed warnings about planetary conjunctions on tortoise shells, he wasn't just predicting events, he was reminding rulers that power, like the stars, comes with conditions. In China's sky-watching tradition, we see the birth of astrophysics and political science intertwined, proving that sometimes to understand an empire's heartbeat, you must first learn to read the stars. In the ancient forests and river valleys where Hindu sages composed the Vedas, the cosmos wasn't just a static backdrop, it pulsed with breath. Time stretched across unfathomable scales, each universe rising like a bubble in an endless ocean, only to dissolve and reform again in cycles called kalpas. The Rig Veda, composed over 3,000 years ago, captured this cosmic rhythm in a hymn that still resonates. Darkness there was at first, concealed in darkness, all this was indiscriminate chaos. Yet within that chaos lay an astonishing insight. The sun wasn't just a deity riding a chariot across the sky, but a star among stars, as the texts describe it, fixed in the midst of the worlds like a hub in a wheel. This vision of an infinite, cycling universe found mathematical expression in the work of Aryabhatta, a 5th-century astronomer who calculated Earth's circumference within 1% of modern measurements, all while proposing that planets orbited due to gravity-like forces centuries before Newton. His Aryabhatiya even suggested Earth's rotation, noting that the star's apparent movement was an illusion caused by our planet spinning, like a potter's wheel. Meanwhile, the Surya Siddhanta, a sacred astronomical text, estimated the moon's distance from Earth at about 238,000 miles, remarkably close to today's figure of 239,000. These weren't guesses, they were products of meticulous observation, often conducted in temple observatories where priests doubled as scientists. Temples themselves became celestial instruments. The Sun Temple at Konark, shaped like a colossal chariot with 12 pairs of stone wheels, was designed so the first rays of dawn would illuminate the inner sanctum during solstices. At Chidambaram, the Nataraja temple's layout mirrored the positions of stars in the Orion constellation, linking Shiva's cosmic dance to actual celestial movements. Even everyday rituals held astronomical precision. The timing of Diwali, for instance, coincides with the new moon nearest the autumnal equinox, symbolizing light's triumph over darkness both spiritually and seasonally. What set Hindu cosmology apart was its embrace of paradox. The universe was both infinite and cyclical, divine and measurable. The Puranas spoke of Brahma's single day spanning 4.32 billion human years, a figure eerily close to Earth's geological age, while also describing time as a child building sandcastles on eternity's shore. This wasn't contradiction, it was layered understanding. When the Mahabharata described multiple suns lighting distant worlds, or the Bhagavata Purana depicted Earth as a sphere floating in space, these ideas coexisted with rituals honoring the sky as a deity. The legacy of these ancient stargazers lingers in modern astrophysics' biggest questions. The concept of an oscillating universe expanding and contracting in cycles mirrors contemporary theories about cosmic inflation and multiverses. Hindu astronomers' insistence on vast timescales predates our understanding of deep geological and stellar evolution. Perhaps their greatest gift was the ability to hold two truths at once, that the cosmos could be both mathematically precise and spiritually alive, that studying the stars wasn't just about charting paths, but about finding one's place in an endless dance of creation and dissolution. Their temples still stand, their texts still whisper, and their vision of a universe both measured and mystical feels more relevant than ever in an age where science and wonder continue their eternal dialogue. Long before telescopes or star charts, the Aboriginal Australians were mapping the heavens in ways that defy modern expectations. They didn't just see constellations, they saw stories etched in the darkness, a celestial library where every star cluster held lessons for survival and morality. Take the emu in the sky, not a pattern of stars but the silvery dust lanes of the Milky Way itself. When its shape stretched fully across the night, it signaled the season to hunt for emu eggs, a nutritional lifeline in the harsh outback. This wasn't casual stargazing. It was an unbroken scientific tradition passed down orally for over 65,000 years, making it the oldest continuous astronomical knowledge on Earth. Across the Pacific, the Lakota people read the sky as a mirror of the prairie. To them, the Pleiades weren't just seven sisters, they were the birthplace of wisdom, their arrival in the winter sky marking the annual renewal of tribal councils. The constellation Wichikiyuhapi, the Big Dipper, served as a celestial compass, its handle pointing toward the North Star like an arrow guiding nighttime travelers. These weren't myths in the modern sense but living navigation manuals. A Lakota elder teaching a child to follow the chief star Polaris was imparting the same practical skills as a naval officer teaching celestial navigation just without the sextant. What sets indigenous astronomy apart is its three-dimensionality. Where Western traditions often fixated on stars as points on a flat dome, cultures like the Polynesians saw the sky as a fluid map. Their star paths, called Kavenga, weren't just about identifying stars but sensing the ocean's swell beneath the canoe while triangulating position by the rise and set of specific stars over the horizon. A navigator memorized hundreds of directional markers, from the zenith star Sirius to the Maui's fishhook Scorpius, which hooked the southern sky. This knowledge allowed voyages across thousands of miles of open Pacific, long before Europeans dared leave sight of land. The Cherokee, meanwhile, wove celestial events into their agricultural calendar. When the hand constellation, our Corona Borealis, stood upright in the spring sky, it was time to plant corn. The appearance of the Great Leech, possibly Orion, in autumn warned of coming frosts. These traditions reveal a truth modern science sometimes forgets, that astronomy's earliest purpose wasn't abstraction but survival. A single misread star pattern could mean missing the salmon run or planting crops too late. Perhaps the most profound aspect of these traditions is their refusal to separate science from storytelling. The Navajo speak of the revolving man, a dwarf star that orbits a brighter companion, a description eerily close to what we now call binary star systems. Their coyote stories, often dismissed as mere folklore, encode warnings about celestial events like solar eclipses, with the trickster's mischief explaining why the sun briefly disappears. This blending of narrative and observation created something unique, a science that was communal, memorable, and woven into daily life. Today, as light pollution erases the stars for many, these oral traditions face extinction. Yet their legacy challenges our definitions of knowledge. When a Maori Tohunga astronomer priest recited a 2,000-line chant to memorize star movements, he was employing a mnemonic system as sophisticated as any database. The Inuit, who named Saturn's rings the eyebrows of the sky, observed details invisible without telescopes simply through generations of sharp-eyed watching. These cultures remind us that the night sky was humanity's first classroom, its lessons written not in ink but in the collective memory of those who understood their lives depended on reading it rightly. Standing stones, pyramids, and mountaintop sanctuaries, these weren't just monuments to human ambition but living celestial calendars carved in stone. Take Stonehenge, its massive trilithons framing the summer solstice sunrise with eerie precision. Those who built it 5,000 years ago didn't just stack rocks, they encoded the rhythms of the cosmos into architecture. On the shortest day of winter, sunlight pours through the great trilithons gap like a key turning in a lock, marking the sun's rebirth. But here's what's astonishing. Stonehenge's builders tracked not just solar events but lunar cycles spanning 18.6 years, evidence hidden in the station stone's alignments. This wasn't primitive sun worship, it was celestial mathematics set in Sarsen. Half a world away, the Incas engineered Machu Picchu as a cosmic dialogue between stone and sky. The Torreon Temple's trapezoidal window frames the Pleiades' rise during the June solstice, a star cluster revered as celestial agricultural advisors. Nearby, the Intihuatana stone, often called the hitching post of the sun, casts no shadow at solar noon during equinoxes, acting as both sundial and spiritual anchor. These alignments weren't decorative, they dictated planting seasons and religious ceremonies, blending survival with the sacred. The Great Pyramid of Giza takes this synergy further. Its descending passage once aligned with the pole star Thuban, guiding pharaohs' souls to the imperishable northern stars. The air shafts in the king's chamber precisely target Orion's belt and Sirius, mirroring the afterlife journey described in pyramid texts. Modern surveys reveal the pyramid's base perimeter divided by its height equals 2 pi, suggesting the builders encoded fundamental mathematical constants into architecture meant to last eternity. What unites these sites is their dual purpose as temples and observatories. Newgrange in Ireland, with its winter solstice lightbox flooding a burial chamber with dawn's first rays, shows how death and rebirth rituals intertwined with solar cycles. At Choco Canyon, the ancestral Pueblones carved spiral petroglyphs that transform into daggers of sunlight during solstices, marking time's passage on canyon walls. These structures reveal a universal truth. Ancient architects saw no divide between measuring the heavens and communing with the divine. The true genius lies in their adaptability. While Western astronomy later prioritized detached observation, these sites embodied participatory science where tracking Venus's cycle wasn't just data collection but a sacred dance with the cosmos. Their stones still whisper secrets that to understand the stars one must stand in their light, that true observation begins with reverence. In an age of satellites and algorithms, these monuments remind us that the oldest telescopes weren't lenses and mirrors, they were human hands shaping stone to touch the sky. For Polynesian navigators, the open ocean was not an empty expanse but a roadmap written in starlight. Without compasses or sextants, they embarked on voyages spanning thousands of miles, guided solely by the rhythmic dance of the heavens. Their secret lay in the star compass, a mental atlas dividing the horizon into 32 directional houses, each marked by the rise and set of specific stars. A master navigator, or PWO, could name over 250 celestial markers, from the zenith star Hoculaire Arcturus to the southern guiding light of Hygianalia Alpha Crucis. But this was more than memorization. It was an intimate dialogue with the sky. They didn't just follow stars. They felt the ocean's swells beneath their canoes, watched the flight patterns of birds, and even detected distant islands by the way clouds clustered above them. The star path, called T-Lapa, flashes of underwater lightning caused by volcanic activity, acted as a natural GPS, visible only to those trained to read its glow. The Vikings, meanwhile, faced a different challenge. Skies often shrouded in fog and clouds. Their solution was the sunstone, a crystal of calcite or cordierite that polarized sunlight, revealing the sun's position even when completely obscured. On the dreariest days, a navigator would hold the stone to the sky, rotating it until light patterns aligned, effectively creating a solar compass. Combined with their sun shadow boards, wooden discs that measured the sun's altitude, they could sail straight to Greenland or Newfoundland without ever seeing a clear horizon. The accuracy was stunning. Modern recreations show Viking routes deviating less than 4% from ideal paths, even across the North Atlantic's treacherous currents. These techniques reveal a universal truth. Celestial navigation was never just about wayfinding, it was about trust. Polynesian navigators whispered chants to the stars, believing them to be ancestral spirits offering protection. Norse sagas spoke of the Vegvisir, a mythical compass that guided travelers through storms, blending practicality with mysticism. Both cultures understood that to navigate by the heavens required more than skill. It demanded humility before the cosmos's vastness. What's often overlooked is how these systems encoded environmental wisdom. Polynesians timed voyages by the Macaulay Pleiades rising, which signaled calm seas, while Vikings waited for the midnight sun, period when the aurora's glow illuminated ice flows. Mistakes weren't merely inconvenient, they were fatal. A misread star path could strand a canoe in the Pacific's endless blue, just as a miscalculated sun bearing might send a longship into pack ice. Today, as GPS satellites orbit overhead, these ancient methods seem obsolete until they don't. In 1976, the Hoculaire canoe sailed from Hawaii to Tahiti using only traditional navigation, proving the system's enduring precision. Modern sailors still learn to use sextants as backup, acknowledging that technology can fail, but the stars remain. The real legacy of these navigators isn't just their routes but their mindset, that the sky is not a mystery to conquer but a partner in exploration, its rhythms as reliable as they are sublime. The night sky has always been humanity's first storybook, and the Zodiac its most universal chapter. From the bustling markets of ancient Babylon to the imperial courts of China, cultures separated by oceans and millennia independently mapped the same celestial territory, carving the sky into symbolic segments that shaped destinies below. The Babylonians, meticulous record keepers of the stars, divided the ecliptic, the sun's apparent path, into 12 equal slices around 2,500 years ago, each named for the constellation it contained. Aries the ram, Taurus the bull, and the rest became more than star patterns. They were cosmic actors in a grand drama where planetary movements dictated everything from harvests to kings' fates. But what's often overlooked is how these signs began as practical agricultural markers. When the sun entered Virgo, it signaled harvest time. Scorpio's appearance warned of coming winter. Only later did they evolve into the personality archetypes we recognize today. Halfway across the world, the Chinese zodiac was weaving its own celestial tapestry, but with a strikingly different approach. Rather than following the sun's path, their system orbited the moon's cycles, assigning each year to one of 12 animals in a repeating sequence. The rat's cleverness, the dragon's power, the rabbits caution these weren't just symbols but reflections of yin and yang balance, tied to the 5 elements of wood, fire, earth, metal, and water. Unlike the Babylonian Zodiac's monthly signs, the Chinese system operated on a grander scale, with each animal governing an entire year's energy. Yet both systems shared a profound insight that celestial rhythms mirrored earthly life, and by reading the stars, one could navigate existence itself. The Maya took this concept even further, integrating their zodiac into the sacred Tzolk'in calendar. Their 13 constellations, including the rarely discussed but vitally important cosmic turtle, aligned with the cycles of human gestation and agricultural seasons. A child born under the sign of the bat Zots was believed to inherit its protective qualities, while the scorpion Sinon signaled transformative potential. What set the Maya apart was their mathematical precision. They could predict planetary positions within their zodiac with accuracy that rivals modern astronomy, all while viewing these calculations as sacred dialogues with the gods. Even cultures we seldom associate with zodiacs left their mark. The Norse saw their gods in the stars Thor's chariot forming Ursa Major, while the Milky Way became the winter road guiding souls to the afterlife. Aboriginal Australians mapped emus, canoes, and creator spirits across the dark spaces between stars, creating a zodiac not of fixed constellations, but of celestial narratives that shifted with the seasons. This diversity reveals a universal truth. The zodiac was never just about prediction. It was humanity's attempt to code the chaos of existence into recognizable patterns, to find our reflection in the stars' glow. Today, as we scroll through horoscope apps, it's easy to forget the depth behind these symbols. The zodiac's real magic lies not in fortune-telling, but in its endurance, a testament to how cultures across time and space all looked up and asked the same question: if the stars shape our stories, do our stories also shape the stars? When the moon's shadow raced across the sun or Earth's umbra swallowed the moon whole, ancient civilizations didn't just witness celestial events, they lived through cosmic emergencies. To the Babylonians, a lunar eclipse wasn't a passive spectacle but a dire warning, a sign their king might be in mortal peril. Their astronomers, huddled atop ziggurats with clay tablets, had decoded a pattern. Eclipses recurred every 18 years and 11 days, a cycle now known as the Saros. With this knowledge, they could issue warnings to substitute a fake king during the eclipse, sacrificing a stand-in to appease the gods while the real ruler hid safely underground. It was a macabre blend of science and theater, where celestial mechanics dictated palace intrigue. Half a world away, Chinese astronomers faced a different kind of celestial drama. As early as 2134 BC, Imperial records describe the sun being eaten by a dragon, an event demanding immediate action. Emperors ordered drums beaten, arrows fired skyward, and crowds to clang parts in a deafening cacophony meant to scare the beast away. Behind the spectacle lay meticulous record-keeping. The Book of Documents notes how 2 court astronomers were executed for failing to predict an eclipse, proof that reading the heavens was a matter of life and death. Yet by the Han Dynasty, their predictions had grown so precise that eclipse dates were used to correct the calendar itself, turning superstition into scientific currency. The Maya took eclipse prediction to another level entirely. In the Dresden Codex, a bark paper book surviving centuries of humidity and conquest, tables track lunar eclipses with a precision that would make modern astronomers nod in respect. Their calculations accounted for the moon's irregular orbit, allowing them to foresee eclipses decades in advance. But this knowledge wasn't just academic, it was survival. When an eclipse darkened the sky, Maya rulers performed ritual bloodletting, offering their own blood to feed the sun god Kinish Ahau and ensure his return. The same priests who calculated celestial mechanics also interpreted them as divine messages, proving that for ancient cultures, the line between astronomer and priest was often invisible. Even in lands where eclipses were rare, their impact was profound. Norse myths describe the wolves Skirl and Hati eternally chasing the sun and moon across the sky when they caught their prey. An eclipse occurred, sparking fears of Ragnarök. In India, the demon Rahu was said to swallow the sun, only for it to reappear when his severed throat let the light escape. These stories weren't mere folklore. They were frameworks for understanding cosmic chaos, turning terror into narrative order. What unites these eclipse traditions is their duality. The same cultures that trembled before eclipses also studied them with razor-sharp precision. Chinese astronomers noted the Bao Yun effect. The corona's glow during totality centuries before Western science named it. Babylonian eclipse records, preserved on cuneiform tablets, now help modern astrophysicists measure Earth's slowing rotation. The tension between fear and fascination birthed something extraordinary, the realization that even the most terrifying celestial events followed discernible rules. In their attempts to control the uncontrollable, these ancient stargazers laid the groundwork for astronomy's greatest triumph, predicting the universe itself. In the remote cliffs of Mali, the Dogon people have guarded a celestial secret for centuries, one that shouldn't have been possible without telescopes. Their oral traditions speak of Sirius, the brightest star in our sky, not as a single point of light but as part of a trio, the visible Sirius A, an invisible companion they called Potolo, and a third star they named Emya. What's astonishing is that modern astronomy confirmed Sirius does indeed have a dense, white dwarf companion, Sirius B, a star so faint it wasn't photographed until 1970. Even more perplexing, the Dogon knew details about its 50-year elliptical orbit and described it as the smallest and heaviest thing, an eerie echo of how white dwarfs pack a sun's worth of mass into an Earth-sized sphere. How could a people without written language or optical instruments possess such precise knowledge? One theory points to their cosmological myths, which describe amphibious beings called Nommo arriving from Sirius in a spinning arc, bringing wisdom to humanity. Some speculate this could hint at contact with an advanced civilization, perhaps even extraterrestrial, though mainstream scholars remain skeptical. Others argue the Dogon's ancestors might have learned of Sirius B from ancient Egyptian or Greek astronomers, though no records from those cultures mention the invisible star. A more grounded explanation lies in the Dogon's own observational brilliance. Living in the arid Bandiagara escarpment, they've spent generations studying the night sky with unparalleled precision. Their priests, trained from childhood in astronomy, track celestial movements using notched calendar sticks and memorized star maps. Could they have deduced Sirius B's existence by noticing Sirius A's subtle wobble, the same gravitational clue that led astronomers to discover the white dwarf in 1862? It's a stretch for naked eye observation, but not impossible over centuries of scrutiny. The controversy deepened when anthropologists noted that early 20th century visitors, including French ethnographer Marcel Graillot, might have inadvertently influenced the Dogon's accounts by sharing Western astronomical knowledge. Yet Graillot's own notes reveal the Dogon spoke of Potolo long before modern Sirius B details were public. Their descriptions of its density and orbit align too closely with scientific facts to dismiss as coincidence. What makes the Dogon's knowledge so compelling isn't just its accuracy, but its integration into daily life. Their agricultural calendar syncs with Sirius's heliacal rising, and initiation rituals encode celestial math into symbolic dances. Whether their wisdom came from star visitors, ancestral memory, or sheer observational genius, the Dogon remind us that the cosmos's deepest truths might still be whispered in the most unexpected places. Their story challenges us to reconsider what discovery really means and who gets to define it. The flames that consumed the great library of Alexandria didn't just burn parchment and papyrus, they erased entire worlds of knowledge. Imagine walking its halls in the 3rd century BCE, where scrolls from Babylon's star priests lay beside Egyptian sky maps and Greek treatises on planetary motion. This wasn't just a repository of texts, it was the ancient equivalent of NASA, Wikipedia, and the Smithsonian combined. Among its treasures were the works of Eratosthenes, a scholar who, using little more than a stick and the sun's shadow, calculated Earth's circumference with an error margin of just 1 to 2%. His method was elegant in its simplicity, measuring the angle of sunlight at noon in 2 cities on the summer solstice. He deduced the planet's curvature. The answer, approximately 25,000 miles, was so accurate that modern satellites confirm it, but the library's true value lay in its diversity. Babylonian eclipse records dating back 700 years shared shelf space with Hipparchus's star catalogue, the first to use magnitude scales for brightness. Egyptian priests had donated their temples' celestial logs, tracking Sirius's movements across millennia. Even more tantalizing are the gaps in our knowledge, like the rumored works of Aristarchus, who proposed a heliocentric solar system 17 centuries before Copernicus, but whose texts vanished in the smoke. The loss wasn't merely historical, it was a fracture in human understanding. When Julius Caesar's siege accidentally set fire to the docks in 48 BCE, and later conflicts finished the destruction, we didn't just lose books. We lost alternate paths to discovery, whole branches of astronomy that might have accelerated our grasp of the cosmos by centuries. The tragedy deepens when we consider the library's role as a collaborative hub. Scholars from across the Mediterranean gathered here to debate, refine, and build upon each other's ideas. Eratosthenes didn't work in isolation. He likely pored over Phoenician sailors' charts and Persian eclipse records to inform his calculations. The library's director, Callimachus, created the Pinax, a catalogue so detailed it became the blueprint for modern library science, organizing knowledge by subject and author. This cross-pollination of ideas was Alexandria's true genius, proving that science thrives not in silos but in conversation. What might have been saved if not for the fires? Hypatia, the brilliant astronomer and mathematician murdered in 415 CE, reportedly worked there on revisions to Ptolemy's star tables. Did her notes contain corrections that could have spared medieval astronomers centuries of error? The library's destruction didn't just halt progress, it sent it reeling backward. Europe would wait until the Renaissance to recover ground that Alexandrian scholars had already gained. Yet, even in its absence, the library's legacy whispers a crucial lesson. Knowledge is fragile, and every scroll lost is a universe of possibilities extinguished. The stars they studied still shine, but the human minds that first decoded their secrets are silent, their voices turned to ashes on the wind. Buried beneath the waves for 2,000 years, the Antikythera Mechanism wasn't just a relic, it was a revolution in bronze. When sponge divers stumbled upon its corroded fragments off the coast of a tiny Greek island in 1901, they had no idea they'd unearthed the world's first analog computer. At first glance, the device resembled a lump of greenish metal, but X-rays later revealed a labyrinth of interlocking gears, precisely calibrated to mimic the cosmos itself. Here was a machine that could predict lunar phases, track planetary movements, and even forecast eclipses decades in advance, all without electricity or microchips, just the turning of handcrafted cogs. The genius of its design still stuns engineers. A main drive wheel, likely turned by a hand crank, set 37 meshing gears in motion, their teeth cut at precise angles to account for celestial irregularities. One gear even reproduced the moon's elliptical orbit using an ingenious pin and slot mechanism that mimicked the physics of gravity. The front dial displayed the Greek Zodiac and Egyptian calendar, while tiny inscriptions, essentially an ancient user manual, explained how to read planetary positions. This wasn't just a tool, it was a portable planetarium, compressing the universe's complexity into a shoebox-sized device. What's most baffling isn't just its existence, but its isolation. Nothing remotely as sophisticated appears in the archaeological record for another 1,000 years. Historians long assumed the ancient Greeks lacked the technical prowess for such precision engineering. Yet here was proof they'd mastered gear ratios and differential mechanisms centuries before these concepts were rediscovered in medieval clocks. The mechanism's creator remains unknown, but clues point to the school of Posidonius on Rhodes, where Cicero himself wrote of a device recently built by our friend Posidonius, which at each revolution reproduces the motions of the sun, moon, and planets. Recent 3D reconstructions reveal even more marvels. The back of the device housed a spiral dial predicting eclipses based on the Babylonian Saros cycle, while another showed the timing of ancient athletic games like the Olympics. Some researchers speculate it could also calculate the positions of Mercury and Venus, planets associated with the gods Hermes and Aphrodite. This blurring of science and mythology was quintessentially Greek, a civilization that saw no contradiction between calculating orbits and interpreting them as divine messages. The Antikythera Mechanism forces us to rewrite history. Its existence hints at a golden age of Greek technology lost to time, where other such devices might have once existed in temples or libraries. Perhaps Archimedes' legendary sphere that modeled the heavens wasn't myth after all. More profoundly, it shatters our assumptions about ancient innovation. If this single survivor from a shipwreck could track the cosmos with near-modern accuracy, what other marvels have vanished into the mists of time? The mechanism's silent gears whisper a humbling truth. Technological progress isn't always a straight line forward. Sometimes it's a treasure waiting centuries beneath the waves to be rediscovered. To the Inca astronomers high in the Andes, the Milky Way wasn't just a band of light. It was Mayu, the great celestial river flowing across the sky, its currents dictating the rhythms of life below. Unlike Western cultures that connected stars into shapes with lines, the Inca saw meaning in the darkness between them. These dark constellations took the form of animals emerging from the cosmic river's shadowy depths. A serpent, a llama, even a shepherd tending his flock, all woven from the dust lanes that streak our galaxy. The llama, in particular, held profound significance when its dark silhouette appeared overhead during the dry season. It signaled the time to drive herds to higher pastures, a celestial reminder etched in the very fabric of the night. This cosmic river didn't just mirror earthly geography, it was geography. The Incas believed the Vilcanota River on Earth was the terrestrial twin of Mayu, its waters reflecting the heavens. Sacred sites like Machu Picchu were positioned so that during solstices, the sun seemed to rise or set along the river's path, binding sky and earth in ritual alignment. But the true brilliance of their cosmology lay in its practicality. When the eyes of the llama, the stars Alpha and Beta Centauri, dipped below the horizon at dusk, it marked the start of planting season. The disappearance of the celestial fox, a dark constellation near the Southern Cross, warned of approaching frosts. Every shift in the sky was a chapter in an agricultural almanac written in starlight. What set the Inca apart was their fluid understanding of time. Rather than rigid calendars, they read the sky's subtle changes like a farmer reads the wind. The Pleiades' brightness at their annual rising predicted rainfall if the cluster shone dimly through haze. Drought loomed, prompting delayed planting. This wasn't superstition but sharp climatology. Modern studies confirm that thin cirrus clouds foreshadowing dry years can obscure the Pleiades' light. Their observations were so precise that Spanish chroniclers noted Inca astronomers predicting solar eclipses, though their methods remain a mystery lost to conquest. The Milky Way's shifting orientation, rotating 90 degrees between seasons, served as a grand celestial clock. During the rainy season, it arched overhead like a bridge between mountains, while in dry months it stretched horizontally, cradling the horizon. This rotation divided the year into 4 quarters, each tied to festivals honoring Earth Pachamama and the Sun Inti. Even today, Quechua elders speak of the sky as a living river, its currents carrying not just stars but the spirits of ancestors watching over the land they once farmed. In this worldview, astronomy wasn't a detached science but a conversation between Earth and sky. A farmer planting potatoes at the Pleiades signal wasn't just following tradition. He was participating in a cosmic dance choreographed millennia before. The Incas remind us that the stars were humanity's first teachers, their lessons written not in equations but in seasons, harvests, and the quiet turning of the heavens. Their legacy lingers in the terraced hillsides of the Andes, where the lines between astronomy, agriculture, and spirituality blur like the shimmering edges of the Milky Way itself. While Europe languished in the so-called Dark Ages, Persian scholars were turning the night sky into a mathematical playground. Take al-Biruni, an 11th century polymath who calculated Earth's circumference with a method so clever it makes modern GPS look crude. By measuring the angle between the horizon and a mountaintop from 2 locations, then applying trigonometry to the height difference, he arrived at a figure just 17 miles off today's measurement. This wasn't ivory tower theorizing. Al-Biruni's work directly improved navigation along the Silk Road, where a single degree of miscalculation could mean missing an oasis by 50 miles. His star catalogue, the Masudic Canon, didn't just list celestial positions, it predicted solar transits and lunar eclipses centuries in advance, blending Hindu, Greek, and Babylonian techniques into something entirely new. Then there was Omar Khayyam, yes, the same poet who penned verses about wine and roses, who reformed the Persian calendar with staggering precision. Commissioned by Sultan Malik Shah, his Jalali calendar corrected seasonal drift so effectively that it accumulated just 1 day's error every 5,000 years, outperforming the Gregorian calendar we use today. Khayyam's observatory in Isfahan housed a massive brass sextant spanning 60 feet, allowing measurements accurate to minutes of arc, but his genius lay in recognizing astronomy's imperfections. Where others sought perfect circular orbits, Khayyam's calculations acknowledged the elliptical paths of planets, a conceptual leap that wouldn't be formalized until Kepler's laws 5 centuries later. The Persian Empire's true gift was its role as the world's first interdisciplinary think tank. At the House of Wisdom in Baghdad, scholars translated Ptolemy's Almagest from Greek to Arabic while simultaneously correcting its errors using Indian sign tables. Zij star tables, combining observations from Damascus to Delhi, became the medieval equivalent of astronomical databases, consulted from Cordoba to Canton. Persian astrolabes, intricate brass computers that could tell time, calculate prayer hours, and even determine the Qibla direction, were so coveted that crusaders brought them back to Europe as prizes. What set Persian astronomy apart was its refusal to treat science as dogma. When al-Biruni encountered Hindu descriptions of Earth as stationary, he didn't dismiss them. He tested the claim by calculating planetary motions from both geocentric and heliocentric perspectives, concluding either model could work mathematically. This intellectual flexibility extended to their instruments. The torquetum, a Persian invention, could switch between equatorial, ecliptic, and terrestrial coordinates with a turn of its dials, embodying their view that truth had multiple angles. Their legacy isn't just in star charts or algorithms, but in proving that scientific progress thrives at cultural crossroads. While wars raged around them, Persian astronomers preserved Greek texts that might otherwise have been lost, refined Indian mathematics, and passed this enhanced knowledge westward, lighting the fuse for the Renaissance. The next time you check your phone's GPS or glance at a weather satellite image, remember, those signals travel along paths first mapped by scholars who saw the sky not as a border but as a bridge. To the Norse mind, the cosmos wasn't a cold void but a towering, living ash tree Yggdrasil, its roots and branches binding 9 worlds in an intricate web of fate. Picture this colossal tree, its trunk piercing the heavens, while one root stretched to the icy realm of the frost giants, another to the land of the dead, and a third to the well of wisdom where the god Odin sacrificed an eye for knowledge. This wasn't just poetic imagery, it was a cosmic map with each realm Asgard's golden halls, Midgard's mortal lands, the fiery pits of Muspelheim connected by the tree's gnarled pathways. Even the squirrel Ratatoska, darting up and down the trunk to spread gossip between the eagle at the crown and the serpent at the roots, played a role in maintaining the universe's delicate balance. Now imagine standing on a frozen fjord under the shimmering aurora borealis, its green ribbons rippling like celestial fabric. To Viking scalds, these weren't mere light displays, but the gleaming armor of the Valkyries, fallen warriors chosen by Odin to ride across the night sky. The northern lights crackled with the energy of their spears, a visible reminder that the boundary between earth and the divine was thinner than a blade's edge. Sailors navigating by the stars saw the aurora as both omen and guide. Its appearance could signal everything from impending storms to the favor of the gods. But Yggdrasil wasn't just a static symbol, it was a universe in flux, constantly under threat. The dragon Nidhogg gnawed at its roots, while 4 stags nibbled its leaves, embodying the Norse understanding of cosmic entropy. Even the tree's fate was tied to Ragnarök, the apocalyptic battle where stars would fall and the earth sink into the sea, only for the cycle to begin anew. This cyclical vision mirrored their observations of nature, the sun's rebirth at winter solstice, the salmon leaping endlessly upstream, the way a fallen tree's seeds sprouted fresh life. What's striking is how Norse cosmology blended the practical and the mystical. The same people who navigated open oceans by reading sunstones and star paths also believed the sky was held up by 4 dwarves named after the cardinal directions. Their rune stones, often carved with celestial alignments, served as both ritual objects and navigational aids. The myth of the sun and moon being chased by wolves wasn't just a bedtime story. It explained why eclipses happened, offering a framework to predict them. The legacy of Yggdrasil endures in unexpected ways. Modern science describes the universe as a vast network of galaxies, clustered like leaves on invisible branches, an echo of the Norse world tree structure. The auroras, now understood as solar particles colliding with Earth's atmosphere, still inspire the same awe they did 1,000 winters ago. The Vikings remind us that the best cosmologies don't just map the stars, they help us find our place in the story, whether we're warriors gazing at the Valkyries' glow or scientists tracing the dendrite-like filaments of the cosmic web. While Western stargazers connected the dots to form Orion's belt or the Big Dipper, Aboriginal Australians were reading the spaces between, the velvety blackness where the Milky Way's dust clouds swirl like cosmic ink. Their emu in the sky isn't made of stars at all, but of the dark patches stretching across the galaxy's spine. Picture lying in the red dust of the outback as an elder points upward, tracing not the glittering points but the shadows between them, a celestial emu with a curved neck, round body, and legs trailing toward the horizon. This wasn't just art in the heavens, it was an ecological bulletin. When the emu's shape stretched full in the April night sky, it meant the real emus below were fat with eggs, signaling the perfect time to hunt. The genius of this system lies in its dimensionality. Where Western constellations are static stick figures, the emu changes posture with the seasons. In early spring, it appears low on the horizon like an emu running, its legs horizontal. By late autumn, it's upright as if sitting on nests, mirroring the behavior of earthly emus. Some clans even saw gender distinctions: the female emu in the dust lanes of the Coalsack Nebula, while the male was represented by the stars of the Southern Cross. This wasn't mythology, it was an intricate ethno-astronomical field guide, passed down through songlines, oral maps that wove celestial knowledge into every verse. Practicality shaped every interpretation. The Borong people of Victoria saw the same Coalsack Dark Nebula as a territorial dispute between two black swans, its shifting shape predicting seasonal conflicts over waterholes. In Arnhem Land, the morning star Venus wasn't just a bright dot but Barnumber, a creator being who led souls to the afterlife on a rope of light. These stories encoded survival data. When Barnumber appeared certain ways at dawn, it signaled the arrival of monsoon rains or the movement of fish schools. What's revolutionary is how Aboriginal astronomy collapses the artificial divide between science and storytelling. The Kamilaroi people's tale of the warrior Bayam chasing the emu across the sky isn't just folklore, it's a mnemonic for tracking the Milky Way's rotation through the year. The Walpiri read the sky as a mirror of the land, where celestial ancestors walked paths that correspond to actual water sources and trade routes. Their star maps weren't drawn on paper but sung in ceremonies, each verse a waypoint in a vast mental atlas stretching back 65,000 years. Modern astrophysics now confirms the brilliance behind these traditions. The dark nebulae forming the emu are actually interstellar dust clouds 70 light-years across regions where new stars are born. The Aboriginal descriptions of the Coalsack as a void align with our knowledge of it being a dense molecular cloud blocking starlight. Even their seasonal interpretations hold up. Emus do indeed fatten and nest in sync with the emu constellation's appearance, proving these weren't arbitrary myths but generations of precise ecological observation. The emu in the sky challenges us to expand how we define astronomy. Where telescopes magnify, Aboriginal knowledge deepened through naked eye observation over millennia. Where Western science often isolates celestial mechanics from earthly consequences, Indigenous cosmology sees them as threads in the same living tapestry. The next time you gaze at the Milky Way, try looking beyond the stars. Sometimes the most profound truths are written in the darkness between them. The ancient world saw geometry not as mere mathematics, but as the hidden language of the divine, a code etched into the very fabric of the cosmos. In Egypt, the Great Pyramid's base perimeter divided by its height yields a ratio startlingly close to 2 times pi, suggesting its builders encoded fundamental constants of the universe into stone. But this was no accident of architecture. The pyramid's angles mirrored the sacred triangle 3-4-5, a right-angled shape revered for its perfect proportions, believed to channel celestial energies toward the pharaoh's ascent to the stars. Similar principles guided India's temple builders, who constructed mandalas, intricate geometric designs. As microcosms of the universe, their concentric squares and circles symbolizing the ordered layers of creation from earth to heaven. Plato took this further, declaring that the 5 Platonic solids tetrahedron, cube, octahedron, dodecahedron, and icosahedron were the building blocks of reality itself. Each shape corresponded to an element: fire's sharpness to the tetrahedron, earth's stability to the cube, air's lightness to the octahedron, water's fluidity to the icosahedron. The dodecahedron, with its 12 pentagonal faces, was reserved for the heavens, a shape so perfect it represented the constellation of the cosmos. This wasn't just philosophy, it was proto-physics. Johannes Kepler, centuries later, would obsess over fitting the planet's orbits into nested Platonic solids, convinced he'd uncovered God's geometric blueprint for the solar system. Islamic scholars elevated sacred geometry to an art form, adorning mosques with tessellating star patterns that symbolized infinity. The Alhambra's walls bloom with repeating octagons and interlocking hexagons, not as decoration but as meditation on unity, each shape a reflection of divine harmony. Beneath the beauty lay rigorous mathematics. These designs required advanced understanding of symmetry groups, a concept Western mathematics wouldn't formalize until the 19th century. The same principles appear in China's Lo Shu magic square, where numbers arranged in a 3x3 grid always sum to 15 in every direction, a pattern linked to the 8 trigrams of the I Ching and the balance of yin and yang. What unites these traditions is the conviction that geometry bridges the seen and unseen. When Gothic cathedral architects plotted their soaring vaults using the golden ratio, they weren't just chasing aesthetic perfection. They believed these proportions resonated with the harmony of creation. The Maya stepped pyramids, with their 9 levels representing the underworld's layers, or the Hindu Sri Yantras intersecting triangles symbolizing cosmic union, all whisper the same truth, that the universe speaks in angles and arcs. Today, as physicists trace the geometric patterns of quantum fields or the hexagonal storms at Saturn's poles, we're still chasing the ancient dream that in the perfect turn of a circle or the spiral of a galaxy, we might glimpse the scaffolding of reality itself. For the ancient Egyptians, every sunset wasn't just a daily occurrence, it was a life or death drama playing out on a cosmic scale. As Ra, the sun god, steered his golden bark across the sky, his journey took a perilous turn at dusk. Entering the underworld through the western horizon, he faced Apophis, a monstrous serpent embodying chaos and darkness. For 12 hours, Ra battled through the night, his light dimmed but never extinguished until he emerged victorious at dawn, reborn as the scarab beetle Khepri. This wasn't just mythology, it was a celestial allegory for the fragile balance between order and chaos, where even the sun's daily return wasn't guaranteed without divine effort. Now imagine the terror when that struggle became visible when the sun itself seemed to falter in broad daylight. During a solar eclipse, Egyptians believed Apophis had momentarily triumphed, swallowing Ra's bark whole. Temple rituals kicked into overdrive, priests clanged sistrums, crowds beat drums, and offerings piled high to strengthen Ra's resolve. The most chilling accounts describe pharaohs personally spearing ceramic models of Apophis, acting as the god's earthly champion. This wasn't superstition, it was crisis management for a universe they believed depended on human participation to keep functioning. Across the Atlantic, the Maya saw their own version of this battle. Their sun god, Kinish Ahau, transformed nightly into the jaguar deity of the underworld, navigating a gauntlet of hostile spirits. But during an eclipse, it wasn't just a transformation, it was an attack. The Dresden Codex depicts eclipses as moments when a celestial monster, often a serpent or a dark bird, took a bite from the sun. Maya rulers responded with bloodletting rituals, piercing their tongues or genitals to offer life force as fuel for Kinish Ahau's rebirth. Archaeologists have found stingray spines and obsidian blades buried with kings, tools for these sacred acts of cosmic maintenance. The Aztecs took the stakes even higher. Their fifth son, Tanatea, required a constant diet of human hearts to keep moving, a belief that turned eclipses into existential emergencies. When the sun darkened, they feared the world might slip back into the void that had consumed 4 previous suns. The Florentine Codex records mass sacrifices during eclipses, with victims' still beating hearts offered to rekindle Tanatea's strength. Gruesome as it seems, this reflected a profound worldview. The universe wasn't self-sustaining but required active upkeep, with human rituals as vital as the stars themselves. Even cultures without pyramids shared this solar anxiety. Norse myths describe the wolves Skurll and Hati eternally chasing the sun and moon. An eclipse meant one had caught its prey. Chinese emperors issued formal apologies during eclipses, believing their misrule had angered heaven. The Hindu demon Rahu, his head severed by Vishnu, eternally chased the sun to swallow it in revenge, only for the severed throat to let the sun escape, explaining why eclipses ended. What unites these myths is their visceral urgency. Unlike distant constellations or wandering planets, the sun's disappearance struck at humanity's most basic fear, the loss of light and warmth. Yet within that fear lay the seeds of scientific inquiry. By meticulously recording eclipse patterns, priests in Babylon, China, and Mesoamerica began predicting them, transforming terror into calculation. The same impulse that made an Aztec priest offer his blood also drove Mayan astronomers to track Saros cycles, proof that wonder and fear have always been astronomy's twin engines. These stories remind us that ancient sky watchers didn't just observe the cosmos, they lived within it, their rituals as much a part of the celestial order as gravity. When we look back at their eclipse panics, we're seeing the birth pangs of a revolutionary idea, that the universe follows rules we can discern, even if we once thought those rules required blood to keep them running. The Star of Bethlehem has shimmered through history not just as a celestial event, but as one of astronomy's greatest unsolved puzzles. For centuries, scholars have scoured ancient skies for clues, debating whether this luminous guide from the Nativity story was a miraculous sign or a rare astronomical phenomenon. One compelling theory points to a spectacular planetary conjunction, a moment when Jupiter and Saturn appeared to merge in the constellation Pisces in 7 BCE. To Babylonian astrologers, this would have been an unmistakable omen. Jupiter symbolized kingship, Saturn represented justice, and Pisces was tied to ancient Israel. The alignment would have blazed like a single brilliant star, visible for months as it drifted westward, mirroring the biblical account of the star going before the wise men. Others argue for a different cosmic spectacle, a nova or supernova flaring suddenly in the night sky. Chinese astronomical records from around 5 BC note an inviting star that glowed for 70 days near the constellation Aquila, a detail that aligns eerily with the Gospel timeline. Unlike planets, a supernova would have remained fixed against the stars, possibly hovering over a specific location as described in Matthew. Modern telescopes have even identified a candidate remnant near the galactic center, RCW 86, which may mark the aftermath of such an explosion. Yet the mystery deepens when we consider the star's reported behavior. The Bible describes it not just appearing, but moving, halting over Bethlehem in a way that defies natural celestial motion. Some scholars propose this could reflect an atmospheric phenomenon like a parhelion, where ice crystals bend sunlight into phantom suns that seem to drift. Others suggest it might symbolize a spiritual rather than physical light, an interpretation favored by early church fathers like Origen. What makes the Star of Bethlehem so endlessly fascinating isn't just the question of its origin, but what it reveals about how humans have always sought meaning in the skies. Whether as a divine miracle or a once-in-a-millennium alignment, this celestial beacon reminds us that the boundary between astronomy and wonder has always been beautifully blurred. The night sky that guided ancient magi still invites us to look up and question not just what we see, but why we see it. Imagine sailing across thousands of miles of open Pacific with no compass, no maps, just the stars as your guide. This was the daily reality for Polynesian navigators, whose mastery of the night sky turned the vast ocean into a highway. At the heart of their expertise lay the star compass, not a physical tool but a mental map etched into memory through generations of training. Picture the horizon divided like the face of a clock, with 32 directional houses, each marked by the rise and set of specific stars. From the zenith star Oculaire Arcturus blazing directly overhead to the southern anchor of Hygianalia Alpha Crucis, every point of light served as a celestial signpost. What set this system apart was its dynamism. Unlike Western compasses fixed to magnetic north, the Polynesian star compass rotated with the night sky, requiring navigators to mentally adjust their bearings as stars ascended and descended. A star rising due east at dusk might shift northeast by midnight, demanding real-time recalibration. Master navigators, or PWO, didn't just memorize static positions. They internalized the sky's choreography, knowing that when the Pleiades dipped toward the horizon at dawn, it signaled the approach of the trade wind season. The training was grueling. Apprentices spent years memorizing over 250 stars, learning to recognize them even when only partially visible through clouds. They studied wave patterns, cloud formations, even the flight paths of birds like the Monu-o-ku white tern, which never ventures more than 40 miles from land. The ocean itself became a textbook. The way swells bent around islands created refraction patterns detectable miles away, while bioluminescent plankton glowing in disturbed water hinted at unseen atolls. Most astonishing was their use of tilapa underwater lightning. These brief, streaking flashes of light caused by volcanic activity or disturbed sediment were visible only to trained eyes on moonless nights. Navigators could follow these pulses like runway lights, guiding canoes to distant islands long before land appeared on the horizon. Modern scientists still debate tilapa's exact cause, but its effectiveness is undeniable. Hawaiian oral histories describe voyages to Tahiti made solely by tracking these submerged beacons. The legacy of this knowledge nearly vanished under colonial suppression, but the revival of the Oculaire voyaging canoe in the 1970s proved its enduring accuracy. Sailing from Hawaii to Tahiti in 1976 without instruments, navigator Maupiailug used only the star compass and natural signs, arriving within miles of his target after 34 days at sea. His success wasn't just a cultural revival, it was a living demonstration that the oldest navigation system on Earth could outperform modern technology. In an age of GPS, the star compass reminds us that true navigation isn't about coordinates on a screen, but about kinship with the natural world. Every star, every ripple of current, every cry of a seabird was a thread in a vast tapestry these navigators learned to read by heart. Their voyages weren't just crossings, they were conversations with the cosmos, written in wind, waves, and the unwavering light of distant suns. Weighing over 24 tons and stretching nearly 12 feet across, the Aztec Sun Stone isn't just a relic, it's a frozen explosion of cosmic philosophy carved into basalt. Often mistaken as a simple calendar, this monolithic masterpiece reveals how the Aztecs saw time as a living, breathing force, pulsing with cycles of creation and annihilation. At its center blazes the face of Tanatia, the sun god, his tongue protruding like an obsidian knife, not in aggression but in thirst for the human hearts that fueled his daily journey across the sky. Surrounding him are 4 square panels depicting the 4 previous suns or eras, each destroyed by cataclysms, jaguars, hurricanes, fiery rain, and floods, a reminder that even the cosmos lived on borrowed time. The stone's intricate rings unfold like chapters of a celestial manuscript. The first ring out from Tanatea's visage contains 20 glyphs representing the days of the Aztec month, each more than just a name, they're portals to divine forces. The crocodile day Cipactli symbolized primordial chaos, while the flower day Xochitl embodied artistic inspiration. Together, these 20 signs rotated through 13 numerical coefficients, creating the 260-day sacred cycle called the Tonalpohuele, the count of days. This wasn't just a calendar, it was a divination tool governing everything from baby naming ceremonies to military campaigns. Priests consulted it to determine auspicious dates, believing each day carried unique energies that could make or break human endeavors. But the true genius lies in how the Sun Stone harmonizes this sacred count with the solar year. A second outer ring depicts the Xupohuele, the 365-day agricultural calendar divided into 18 months of 20 days each. The 5 leftover days, called Nemontemi, were considered dangerously unlucky, a time when the boundaries between worlds grew thin. Together, these 2 calendars interlocked like gears in a cosmic clock, synchronizing only once every 52 years, a cycle so significant it sparked the terrifying new fire ceremony. As this convergence approached, Aztecs extinguished all fires, shattered pottery, and waited in darkness atop Mount Huaxtlan. If the Pleiades crossed the zenith at midnight, priests would kindle a new flame in a sacrificed captive's chest, signaling the cosmos had granted another 52-year reprieve. Hidden within these circles are even deeper layers of meaning. The 8 radiating arrows or rays surrounding Tanatia don't represent sunlight but the cardinal and intercardinal directions, each governed by specific deities and cosmic forces. The band of starry eyes encircling the stone may depict the constellation Orion or the starry heavens themselves, watching over human affairs. Recent studies suggest the entire disk might have functioned as a colossal sundial, with shadows tracking solstices along its carved ridges. What makes the Sun Stone revolutionary is its refusal to separate astronomy from existential philosophy. Where modern calendars mark time in neutral numbers, the Aztecs embedded each day with spiritual weight. A farmer planting maize consulted both the solar calendar for seasonal timing and the sacred count to ensure the day's energy favored growth. Warriors timed battles to coincide with the eagle day Cuautli for victory, while merchants avoided the wind day Ehecatl lest their profits blow away. This wasn't superstition, it was a sophisticated system recognizing humanity as participants in cosmic rhythms, not mere observers. Today, the Sun Stone's legacy lingers in unexpected places. Mexico's modern flag bears an eagle perched on a cactus, a direct reference to the glyph for Tenochtitlan found on the stone's edge. Its interlocking calendars inspired early computer scientists studying cyclical algorithms, while its imagery fuels artistic movements from murals T-O Chinese letter, Chinese letter, Chinese letter. But perhaps its greatest lesson is timeless. That true understanding of the heavens isn't just about tracking days, but about seeing our own stories reflected in the stars' endless dance. The serpent slithers through the mythology of nearly every ancient civilization, not as a mere creature but as a cosmic architect weaving the universe together. In Egypt, the Ouroboros, a serpent swallowing its own tail, encircled hieroglyphs and temple walls as the ultimate symbol of eternity. This endless loop represented not just cyclical time, but the very fabric of existence, death feeding into rebirth, endings birthing new beginnings. The same image adorned alchemical texts millennia later, a testament to its enduring power. But the Egyptians took the symbolism further. The god Atum, creator of all things, was said to transform into a serpent each night to navigate the underworld's darkest realms, merging the serpent's form with the sun's regenerative journey. Across the Atlantic, the Mayan feathered serpent Kukulkan wasn't just a deity, it was a celestial equation given physical form. Its scales mirrored the diamond-shaped patterns of light and shadow that slithered down El Castillo Pyramid during equinoxes, a stone and sun spectacle that drew thousands to Chichen Itza. Kukulkan embodied duality, earth and sky, matter and spirit, the tangible and the divine. When Spanish chroniclers described temples where priests channeled the serpent's voice during rituals, they were witnessing the living expression of a belief system where cosmic forces took audible form. The serpent's movement even mapped to astronomy. The Milky Way was often depicted as a great snake, its undulating path across the night sky mirroring the earthly rivers that sustained Mayan cities. Nor were these isolated parallels. In Hindu cosmology, the serpent Shesha floats coiled in the cosmic ocean, its 1,000 heads supporting the universe while Vishnu rests upon it. Each time Shesha uncoils, a new cycle of creation begins. Each time it coils back, the universe dissolves, a direct echo of the Ouroboros. Norse myths told of Jormungandr, the world serpent so vast it encircled Midgard with its tail in its mouth, its stirrings causing earthquakes and tides. Even the Aboriginal rainbow serpent carved waterways into the Australian landscape with its sinuous body, linking geography to celestial patterns in Dreamtime stories. What makes the cosmic serpent so universally compelling is its fluid ability to represent opposing forces in harmony. Its shedding skin symbolizes renewal, yet its venom brings death. It slithers on the ground, but in Mesoamerican art, it soars with quetzal feathers. The Greek caduceus twin serpents winding around a staff later became a medical symbol, merging the serpent's duality into healing and balance. These cultures, separated by oceans and centuries, all arrived at the same profound insight, that the universe operates not in straight lines but in spirals and loops, that destruction and creation are two faces of the same scale-covered coin. Modern science unknowingly echoes this ancient wisdom. The double helix of DNA mirrors the serpent's coiled form, while astrophysicists map the universe's large-scale structure as a web of filamentary, cosmic snakes connecting galaxies. Perhaps these converging visions reveal a deeper truth, that when humanity seeks to understand life's greatest mysteries, we keep returning to the same primal shapes. The serpent isn't just a symbol, it's the original teacher whispering that to know the cosmos, we must first learn to think in cycles. The precision of the Great Pyramid's alignment with true north isn't just impressive, it's nearly inexplicable. To grasp the magnitude of this feat, consider that its base is oriented to within just 3/60ths of a degree of perfect alignment, a margin of error so slight it would rival modern surveyors using GPS technology. How did builders working 4,500 years ago without compasses or advanced optics achieve such accuracy? One compelling theory points to the ancient Egyptians' mastery of the stars. They may have used a method called the simultaneous transit, tracking two circumpolar stars, likely Kochab in the Little Dipper and Mizar in the Big Dipper, as they rotated around the celestial pole. By bisecting the angle between these stars at a key moment, they could pinpoint true north with astonishing precision, but the stars weren't their only guides. Another possibility lies in the humble merkit, a simple yet ingenious tool consisting of a palm rib with a slit and a plumb bob. Used as a primitive theodolite, It allowed priests to sight stars along the slit's edge while the plumb line ensured vertical alignment. Recent experiments show that by observing the rising and setting of a single star over several nights, a skilled observer could establish a north-south line with minimal error. This technique, combined with the Egyptians' obsession with symmetry, might explain how they laid out the pyramid's 4-acre base with such exactitude. The mystery deepens when we examine the pyramid's corners, which form near-perfect right angles despite the absence of modern measuring tools. Some researchers suggest the builders used a grid of ropes and stakes, soaked in water to shrink uniformly and maintain consistent tension. Others propose they employed the Pythagorean theorem millennia before Pythagoras, creating 3-4-5 triangles to verify right angles, a method evident in later Egyptian architectural manuals. Yet the most tantalizing clue lies in the pyramid's relationship to the Nile. The river's annual flooding left behind fertile silt but also erased all surface markers, forcing engineers to develop techniques independent of terrestrial landmarks. By aligning their constructions to celestial rather than earthly references, they created monuments resistant to the river's whims, a testament to their understanding that the stars, unlike the land beneath them, were unchanging guides. Modern attempts to replicate the pyramid's alignment reveal just how sophisticated the builders' methods must have been. In 1978, astronomer Virginia Trimble demonstrated that even using ancient tools, achieving such precision required not just technical skill but a profound cultural commitment to celestial order. For the Egyptians, aligning the pyramid wasn't merely an engineering challenge, it was a sacred act, ensuring the pharaoh's soul could ascend along the same axis that connected Earth to the imperishable northern stars. What makes the pyramid's alignment truly remarkable isn't just the how but the why. In a civilization where architecture mirrored cosmology, every perfectly placed stone reinforced the belief that earthly power derived from celestial harmony. The pyramids weren't just tombs, they were frozen prayers in stone, their sides whispering to the heavens in a language of angles and light. Today, as astrophysicists use satellites to study cosmic background radiation, we're still chasing the same goal as those ancient architects: to find our place in the universe by reading the sky's silent geometry. High above the Aegean Sea, where the Milky Way arches like a bridge between worlds, the ancient Greeks spun stories in the stars that still shape how we see the night sky. Orion the hunter strides across the heavens with his belt of 3 glittering stars, forever locked in battle with Taurus the bull, a celestial drama playing out nightly. But this constellation wasn't just a collection of bright dots, it was a cautionary tale. According to myth, Orion's boast that he could slay all Earth's creatures angered the goddess Gaia, who sent a scorpion to kill him. Zeus immortalized both hunter and scorpion in the sky, ensuring they'd never meet. When Scorpius rises in the east, Orion flees below the western horizon, an eternal chase written in starlight. The Greeks didn't merely name constellations, they gave them soul. Hercules kneels in the northern sky, his club raised mid-labor, commemorating the demigod's 12 impossible tasks. His story wasn't just entertainment, it encoded values of perseverance and humility. Even the delicate Pleiades, those 7 sisters fleeing across the heavens, carried layered meaning. Their myth of being pursued by Orion until Zeus turned them into stars doubled as an agricultural marker. When the Pleiades disappeared in spring, it signaled safe sailing season. Their autumn return warned of storms. The stars were both storybook and almanac, their light illuminating moral lessons as clearly as they guided ships. Roman astronomers adopted these Greek myths but added their own imperial flair. Where the Greeks saw a charioteer in Auriga, the Romans envisioned their founding ancestor, Eratosthenes, whose lameness didn't prevent him from inventing the quadriga war chariot. The constellation Lyra, to the Greeks the lyre of Orpheus, became for Romans the harp of Emperor Nero, its stars plucked in celestial concerts. This cultural remixing reveals how constellations served as mirrors, each civilization projecting its heroes and fears onto the cosmic canvas. The true genius of these star myths lies in their duality. The tale of Perseus rescuing Andromeda from Cetus the sea monster not only explained why those constellations appear in sequence, but also modeled ideal behavior for young Greeks. When farmers saw Cassiopeia's W shape inverted like a punished queen's throne, they remembered the vanity that doomed her daughter to the monster's rocks. Even the Milky Way's hazy band became the spilled milk of Hera's breast, a divine accident frozen overhead. What modern stargazers often miss is how these myths encoded scientific observation. Orion's sword, a fuzzy patch below his belt, is actually the Orion Nebula, a stellar nursery the Greeks couldn't have understood yet marked as significant. The myth of the twins Castor and Pollux in Gemini reflects that one star is bright and steady Pollux while the other flickers Castor, as if the mortal twins' light wavers. These stories preserved celestial knowledge long before telescopes, proving that myth and science once walked hand in hand across the star fields of human imagination. The legacy of these star myths endures every time someone traces Hercules' shape or spots Ursa Major's tail. They remind us that the night sky was humanity's first theater, its dramas teaching us about courage, folly, and our small but storied place in the cosmos. The Greeks and Romans didn't just connect the dots, they gave us constellations with beating hearts, their myths whispering across millennia that the stars are more than distant suns. They're the immortalized dreams of everyone who ever looked up and wondered. In the Forbidden City's shadow, where whispers could cost lives, China's imperial astronomers worked under a mandate heavier than the bronze instruments they wielded. Their star maps weren't just scientific records, they were dynastic lifelines, locked in lacquered cabinets like state secrets. Every flicker in the night sky carried political weight. A comet's tail might signal rebellion, while a guest star, what we now call a supernova, could herald the emperor's downfall. The Tang Dynasty's star catalogue, compiled in the 8th century, listed over 1,300 stars with positional accuracies rivaling modern measurements, yet its true value lay in the margins where scribes noted celestial events alongside court scandals and border wars, drawing lines between heaven's movements and earthly power struggles. One of history's most dramatic examples unfolded in 1054, when a star blazed so brightly it outshone Venus for 23 days, visible even at noon. Court astronomers dubbed it a guest star, carefully recording its position near Taurus. What they'd witnessed was actually the Crab Nebula supernova, a stellar explosion modern telescopes still study today. But to Emperor Renzong, this wasn't astrophysics, it was a divine performance review. Chronicles describe him canceling celebrations, reducing taxes, and even drafting a public apology to heaven for his shortcomings. The astronomers' predictions became policy. When their calculations suggested celestial discord, imperial edicts would delay military campaigns or replace unpopular ministers, all to rebalance the cosmic order. The tools behind these forecasts were engineering marvels. The armillary sphere, a bronze rings-within-rings contraption standing 3 meters tall, tracked planetary movements with jeweled precision. Its smaller cousin, the abridged armilla, served as the emperor's personal sky calculator, its rotating bands simulating celestial motions for private consultations. Yet the most consequential instrument was the simplest, a clepsydra water clock, so accurate it could measure the exact moment a star crossed the meridian. its dripping water synchronized with the heavens' heartbeat. What set Chinese astronomy apart was its bureaucratic rigor. While Babylonian stargazers focused on planetary cycles and Maya priests calculated sacred dates, China's Astronomical Bureau operated like a celestial intelligence agency. Regional observatories across the empire sent nightly reports via courier relays, creating a surveillance network that monitored the sky for omens as intently as border guards watched for invaders. The 24 Histories, official dynasty records, devoted entire chapters to celestial phenomena, their dry notations belying the panic they often triggered. A single entry from 1680 BC reads, "On the Jayayan day, the last day of the month, the sun was eclipsed. The emperor did not eat meat at the evening meal." This system reached its zenith under the Jesuits' surprising influence. When Matteo Ricci arrived in Beijing in 1601, he won imperial favor not with Bibles but with star charts, his hybrid European-Chinese maps so accurate they shamed the court astronomers. The resulting collaboration produced the Chongzhen Emperor's revised calendar, which corrected 3 centuries of accumulated errors. Yet even this scientific triumph carried political stakes. When the Jesuits' eclipse prediction outperformed the imperial astronomers in 1629, heads literally rolled. The Bureau's chief was imprisoned for his failure, proving that in imperial China, celestial calculations were never just about the stars. The legacy of these star maps endures in modern astronomy's unlikeliest places. When NASA scientists needed historical supernova data, they turned to Chinese records. The Chinese Historical Supernova Catalog has become a gold standard, its meticulous observations helping track stellar evolution across millennia. Yet perhaps the true lesson lies deeper, in recognizing how these astronomers, bound by tradition and terror, still pushed human understanding forward. Their star maps were acts of devotion to an ideal we still chase, that by reading the heavens rightly, we might finally grasp our place within them. High on a mesa in Arizona, where the sky stretches endless and clear, a sandstone boulder bears ancient carvings that whisper of celestial cataclysms. Hopi Prophecy Rock isn't just a petroglyph, it's a cosmic ledger. Its spirals and figures telling a story of destruction and rebirth written in the language of the stars. At first glance, the symbols seem simple, a human figure, a crescent, a circle with radiating lines. But to the Hopi, these aren't abstract shapes. They're a timeline of past and future, encoding both the memory of a blinding supernova and a warning about the world's cyclical unraveling. Central to the petroglyph is the Kachina figure, its head crowned by a star-like burst. Some elders interpret this as the Great Conjunction, a rare alignment of planets that occurs every 500 years, while others see the Crab Nebula supernova of 1054, whose light would have blazed across Hopi ancestors' skies. The crescent below may represent the moon's role as a timekeeper, its phases dictating ceremonial cycles, but the most striking element is the path splitting at the rock's base, one line smooth, the other jagged. This, say Hopi tradition keepers, maps humanity's choice between harmony with nature or catastrophic discord, a decision point reflected in the heavens themselves. What makes this rock art extraordinary is how it merges astronomy with prophecy. The Hopi, like the Maya, perceived time as a wheel rather than a line. Their creation stories speak of 3 previous worlds destroyed by fire, ice, and flood, events some scholars suggest could encode memories of comet impacts or volcanic winters. The petroglyph's spiraling motifs mirror this cyclical view, echoing the spiral arms of our Milky Way and the helical rising of stars. Even the rock's placement matters. It faces east, aligning with the sunrise on equinoxes when the sun's light illuminates specific carvings, turning stone into a solar calendar. Modern astrophysics adds eerie resonance to these interpretations. The star symbol's radiating lines match how supernovae appear in telescopic images, while the split path aligns with the Hopi concept of Pahana, a lost white brother who would return bearing both wisdom and danger. Some researchers speculate this could symbolize cyclical encounters with a hypothetical companion star to our Sun, whose gravitational perturbations might trigger comet showers every 26,000 years. Whether coincidence or encoded knowledge, the parallels challenge our assumptions about how ancient cultures processed celestial events. Unlike Western astronomy's focus on prediction and control, the Hopi world sees humans as active participants in cosmic balance. The petroglyph isn't just a record, it's a reminder that earthly actions ripple through the stars. When elders speak of the blue star Kachina's impending return, said to herald the fifth world's dawn, they're not passively awaiting fate. They're upholding rituals to maintain the delicate equilibrium between sky and earth, proving that sometimes the oldest star maps aren't drawn on paper but etched in stone and spirit. The rock's true power lies in its unfinished story. The lower half remains blank, awaiting the carvings of future generations. In this silence, we hear an invitation to look up not just with telescopes but with humility, recognizing that the cosmos speaks in many tongues and some of its deepest truths are still being written. Cracked open across countless creation myths, the cosmic egg isn't just a poetic image, it's the ultimate symbol of potential, a perfect vessel holding the chaos that birthed the universe. In the Rig Veda, one of humanity's oldest texts, the golden Hiranyagarbha floats in the void before splitting into heaven and earth, its yolk becoming the sun and its shell the mountains. The Egyptians told of the primordial mound rising from the waters of Nun, an egg-like island where the god Autumn first stirred into being. Even the Orphic traditions of ancient Greece sang of Phanes, the shimmering deity hatched from a silver egg whose light pierced the darkness to shape the cosmos. What makes this symbol so universal? Perhaps because eggs embody transformation in its purest form, something fragile yet resilient, simple yet containing infinite complexity. The Finnish epic Kalevala describes the world egg laid by a celestial duck on the knee of Ilmater, the air goddess. When it shattered, its fragments became the earth, sky, and stars, while the yolk blazed into the sun. Chinese myth offers a striking parallel. Pangu, the giant born from chaos, cracked the cosmic egg with his axe, its heavier parts sinking to form earth and the lighter bits rising as sky. Each culture's egg story varies, but the core truth remains: creation isn't a neat process, but a messy, almost violent unfurling of order from raw potential. The cosmic egg also reflects ancient observations of natural cycles. Chickens hatching from eggs mirrored the sun's daily rebirth at dawn, while the oval shape echoed celestial bodies like the moon or even Earth itself. The Dogon people of Mali, with their astonishing astronomical knowledge, depicted the egg as the womb of Amma, the creator god, whose spiral movements within it seeded the universe with twin forces of harmony and discord. This duality resonates with modern physics' own cosmic egg, the singularity before the Big Bang, a point of infinite density that hatched the expanding universe we know today. Yet the egg's symbolism goes deeper than mere birth. In many traditions, it represents the cyclical nature of existence. The Phoenician myth of the world egg includes a fascinating detail. When the egg splits, half becomes the dome of the sky, while the other half forms the underworld, suggesting creation and destruction are two sides of the same shell. Norse legends speak of the icy void Ginnungagap, where fire and ice collided to form the giant Ymir, whose body became the world, a story echoing the egg's role as a boundary between opposites. The cosmic egg's legacy endures in unexpected ways. modern astronomers describe the universe's early stages as a quantum foam, bubbling with potential like an egg's fluid contents. The oval shape appears in galactic clusters and planetary orbits, while the very atoms in our bodies carry the imprint of that primordial cracking open. From the golden Hiranyagarbha to the singularity before time, the egg reminds us that every beginning is fragile, chaotic, and radiant with possibility. It's not just a myth, it's the oldest story we keep retelling, written in the atomic alphabet of the stars themselves. Beneath the mist-shrouded hills of ancient Britain and Ireland, where standing stones cast long shadows under the moonlight, the Druids practiced an astronomy now lost to time. Unlike the Babylonians with their clay tablets or the Egyptians with their pyramid alignments, the Celts left no written star charts, yet their silent stone circles whisper of a deep celestial understanding. Take Newgrange in Ireland, a massive passage tomb older than the pyramids, where the winter solstice sunrise pierces its inner chamber like a laser for 17 minutes, illuminating spirals carved into the stone. This wasn't just a tomb, it was a precision-built solar observatory, its alignment so exact that modern reconstructions struggle to replicate its accuracy without computer modeling. The Druids, as the intellectual elite of Celtic society, likely saw the sky as a living manuscript. Julius Caesar, in his Gallic Wars, noted that these priest astronomers memorized vast amounts of knowledge, including the stars and their motions, suggesting an oral tradition of celestial observation passed down through generations. The Coligny calendar, a fragmented bronze artifact found in France, reveals their sophisticated timekeeping, a lunisolar system reconciling moon cycles with the solar year, complete with notations for auspicious and inauspicious days. Interlocking holes along its edges hint at movable components, possibly used to track eclipses or planetary positions. What set Celtic astronomy apart was its fusion of practical and mystical purposes. The standing stones of Callanish in Scotland form a cruciform pattern aligning with the lunar standstill, a rare event where the moon pauses at its extreme northern and southern points in an 18.6-year cycle. Nearby, the Beltany stone circle in Ireland marks the cross-quarter day between spring equinox and summer solstice, a time when the Pleiades cluster vanishes before dawn, a celestial signal for planting crops. Yet these sites weren't just agricultural tools. Legends speak of Druids performing rituals where they read the stars' reflections in sacred pools, interpreting celestial patterns as divine messages. The most tantalizing clues lie in Celtic mythology. The Welsh tale of Lud and Leafleys describes a cosmic scream heard every May Eve, caused by dragons battling in the sky, a possible allegory for meteor showers like the Eta Aquariids that peak in early May. The Irish godlug, associated with the sun, carries a spear that blazes so brightly it must be submerged in water to cool, echoing solar imagery found in artifacts like the Trundholm sun chariot, where a gilded sun disk is pulled by a horse, perhaps symbolizing the sun's daily journey. Even the famous Celtic knotwork, with its endless interlacing loops, may encode astronomical concepts like ecliptic paths or the cyclical nature of time. Modern attempts to reconstruct Druidic astronomy face daunting gaps. The Christianization of Celtic lands suppressed pagan knowledge, and the Druids' oral traditions died with them. Yet scattered fragments survive. The Liber Gabala Iren mentions the Milesians, a mythical race who navigated to Ireland by following the Milky Way called Bealach na Bo Fin, the White Cow's Path. The 4 jewels of the Tuatha Dé Danann include the Lia Fail, a stone said to cry out when touched by the rightful king, possibly linked to solstice alignments at Tara's inauguration site. The legacy of Celtic stargazing lingers in unexpected ways. Some scholars suggest the Halloween tradition of bonfires originated as Samhain celebrations, marking the Pleiades' zenith at midnight, a celestial turning point between seasons. The Green Man carvings found in medieval churches with their foliage spewing faces may descend from older depictions of the sky god Cernunnos, whose antlers mirror the branching paths of the Milky Way. Even the Arthurian legend of the Round Table echoes the circular design of stone circles, where knights like stars gathered as equals under cosmic laws. What the Druids truly knew about the stars may forever remain a mystery wrapped in oak leaves and mist, but their stone sentinels still stand, aligned to solstices and star risings we can measure but may never fully understand. In their silence, they challenge us to consider how much knowledge can be carried in memory, carved in stone, or written in the very landscape, a celestial map not inked on parchment but woven into the world itself. Buried beneath the sands of Mesopotamia for over 3,000 years, the Babylonian Venus tablets are more than ancient ledger entries. They're a window into the moment humanity began transforming celestial wonder into calculable science. Imagine a scribe in the city of Amasajuka pressing wedge-shaped marks into damp clay under the glow of a flickering oil lamp. Each stroke recorded Venus's position with obsessive precision. Its first appearance as the morning star, its dramatic disappearance, its rebirth as the evening star weeks later. These weren't casual notes, they were data points in a sprawling cosmic experiment spanning 21 years, capturing the planet's 8-year cycle with an error margin of just a few days. What's staggering isn't just the accuracy, but the tablet's dual purpose, equal parts scientific almanac and divine telegram. The tablets, known formally as the Enuma Anu Enlil, reveal a civilization that saw no contradiction between math and mysticism. On one column, Venus's movements were logged like clockwork. On another, their implications were decoded as omens. A line might read, "If Venus appears in the east on the 30th day, the harvest will prosper," blending astronomical observation with agricultural prophecy. This wasn't superstition, it was an early form of pattern recognition, where celestial rhythms were linked to earthly outcomes. The Babylonians noticed, for instance, that years when Venus's cycle aligned with certain lunar phases often coincided with droughts or abundant floods. Their predictions were essentially probabilistic models, dressed in the language of the gods. Modern astronomers still marvel at the tablet's sophistication. One section details Venus's retrograde motion, the apparent loop it makes in the sky when Earth overtakes it in orbit. Without telescopes, the Babylonians mapped this phenomenon purely through naked eye observation, correcting their calculations over generations. Their secret, a base 60 numerical system that gifted us the 60-minute hour and 360-degree circle, tools perfectly suited for tracking cyclical celestial events. The tablets even account for observational errors, with later copies adjusting earlier records, evidence of a living scientific tradition refining its methods over time. Yet the true genius of these tablets lies in their humanity. Between the numbers, we catch glimpses of the observers themselves, scribes who noted cloudy nights when Venus was not seen, or who fretted over omens predicting the king will die. One tablet breaks from formula to describe a red glow around Venus, possibly documenting an atmospheric event like a dust storm. These details remind us that science, even at its dawn, was never just cold calculation. It was a dialogue with the cosmos, where every flicker of light carried both mathematical truth and mythic weight. The legacy of the Venus tablets echoes in surprising places. NASA Jet Propulsion Laboratory used their eclipse records to study changes in Earth's rotation over millennia. Modern astrology, for all its differences, still traces its roots to the Babylonian idea that planetary positions influence human affairs. But perhaps their greatest lesson is timeless. That curiosity about the heavens begins not with answers, but with questions about why the stars move as they do, and what their dance might mean for those of us watching below. In the stillness of the cosmos, where galaxies spin and stars are born and die, there is a rhythm, a pulse that ancient Hindu sages captured in the image of Shiva Nataraja, the lord of the dance. With one foot planted on ignorance and the other lifted in liberation, his four arms outstretched in perfect balance, Shiva's dance is more than art, it's a cosmic blueprint. The flames encircling him represent the fiery dissolution of the universe, while the drum in his hand beats the rhythm of creation itself. This isn't just mythology, it's a profound scientific allegory, one that mirrors modern astrophysics with eerie precision. The dance's symbolism runs deep. The crescent moon tucked into Shiva's hair mirrors the cyclical nature of time, waxing and waning like the phases of the moon, while the serpent coiled around his arm echoes the spiraling arms of galaxies. His wild, flowing hair recalls the explosive energy of quasars, and the river Ganga cascading from his locks mirrors the cosmic filaments that weave the universe together. But the most striking detail is the circle of fire, the Prabhamandala, encasing the entire scene. To a modern eye, it's uncannily reminiscent of an atom's electron shell, or even the event horizon of a black hole, where matter is both destroyed and reborn. What makes this metaphor so extraordinary is how it aligns with cutting-edge cosmology. The idea of the universe undergoing endless cycles of creation and destruction. Pralaya parallels theories like the Big Bounce, where the cosmos expands, contracts, and then explodes anew. The Damaru drum in Shiva's hand doesn't just mark time. Its hourglass shape mirrors the cosmic duality of entropy and order, chaos and structure. Even the concept of Ananda Tandava, Shiva's dance of bliss, finds resonance in quantum physics, where particles vibrate in a ceaseless, joyful dance of energy. The connections go deeper than imagery. Ancient texts like the Tirumantaram describe Shiva's dance as unfolding across 5 acts: creation, preservation, destruction, illusion, and grace, each corresponding to a fundamental force. Modern physics, too, speaks of 5 forces including dark energy that govern the universe. Coincidence, perhaps, but when the Vishnu Purana describes universes rising like bubbles in an infinite ocean, dissolving only to reform again, it's hard not to think of multiverse theory or the holographic principle, where our 3D reality is a projection of deeper, hidden dimensions. Yet Shiva's dance isn't just about grand cosmic scales, it's also deeply personal. The raised foot offers liberation, a reminder that even within the universe's endless cycles, there's a path to transcendence. The dwarf beneath Shiva's other foot, Apasmara, symbolizes forgetfulness, the inertia that keeps us from seeing our own place in this cosmic dance. In this way, the metaphor bridges the infinite and the intimate, inviting us to see our lives as part of something vast and rhythmic, where every ending carries the seed of a new beginning. Today, as physicists peer into the quantum foam or map the cosmic microwave background, they're echoing the same questions posed by those ancient sages. What is the nature of reality? How does time truly flow? Shiva's dance, frozen in bronze and poetry, offers no equations, but it captures something science still struggles to articulate. That the universe isn't just a machine to be dissected, but a living, breathing performance where destruction and creation are partners in the same eternal dance. The stargazers of antiquity didn't just watch the sky, they built the very foundation of modern astronomy with nothing but their eyes, their intellect, and an insatiable hunger to understand the cosmos. What began as celestial storytelling, where planets were gods and comets were omens, gradually transformed into rigorous science through centuries of patient observation. The Babylonians' meticulous Venus tablets, tracking the planet's movements with mathematical precision, became the prototype for modern planetary ephemerides. The Mayan Dresden Codex, with its astonishingly accurate eclipse predictions, functioned like an ancient version of NASA solar system simulations. Even Stonehenge, once thought to be merely a ritual site, reveals itself as a sophisticated astronomical calculator capable of marking solstices, equinoxes, and lunar standstills spanning nearly 2 decades. This transition from myth to measurement wasn't linear. It was a dance between wonder and calculation. Greek astronomers like Hipparchus used Babylonian eclipse records to discover the precession of the equinoxes, that slow wobble of Earth's axis that completes a full cycle every 26,000 years. Yet, even as he calculated this cosmic clockwork, he still viewed the stars as divine entities moving through crystalline spheres. The boundary between science and spirituality remained porous, with each informing the other. Chinese court astronomers developed precise armillary spheres to map celestial movements, while simultaneously interpreting those same movements as heaven's judgment on imperial rule. The true legacy of these ancient astronomers lies in their methods as much as their discoveries. The Dogon people of Mali, with their precise knowledge of Sirius B, a star invisible to the naked eye, demonstrate how oral traditions could preserve complex astronomical data across generations. Polynesian navigators memorized hundreds of star paths and ocean currents, creating mental star charts as accurate as any modern navigation app. These weren't primitive practices but sophisticated knowledge systems, honed through millennia of careful observation and testing. Modern astronomy still bears the fingerprints of these early pioneers. The 60-based numbering system we use for time and angles comes directly from Babylonian mathematics. The constellations we recognize today, though formalized by Greek astronomers, often trace back to Sumerian and Egyptian star lore. Even cutting-edge research benefits from ancient records. Chinese observations of guest stars help modern astrophysicists study supernova remnants, while Mayan eclipse data has refined our understanding of Earth's rotational slowing over centuries. Perhaps the most profound lesson from these ancient stargazers is their holistic vision of the cosmos. They never saw astronomy as separate from daily life. The stars dictated planting seasons, guided ocean voyages, and shaped cultural identities. In our age of light pollution and smartphone screens, we've gained unparalleled tools for observing the universe but risk losing that visceral connection to the night sky. The Babylonian who tracked Venus as the goddess Ishtar, the Inca priest who read the Milky Way's dark constellations as agricultural signals, the Greek philosopher who envisioned atoms while contemplating the stars, they all understood something we're still rediscovering: that to study the heavens is to explore both the universe and our place within it. As we trace the footsteps of ancient astronomers, from Babylonian priests tracking Venus's dance to Polynesian navigators steering by star paths, we're reminded that our quest to understand the cosmos is woven into humanity's oldest stories. These stargazers didn't just observe the heavens, they breathed meaning into them, transforming celestial movements into calendars, myths, and even moral compasses. The same stars that guided Mayan farmers planting maize now guide spacecraft navigating the solar system, proving that curiosity transcends time. What's astonishing isn't just the accuracy of their observations, like the Dogon's knowledge of Sirius B or the precision of Stonehenge's solstice alignments, but how they balanced calculation with wonder. The Egyptians didn't merely build pyramids aligned to Orion's belt. They saw them as gateways for pharaohs joining the gods. The Greeks mapped planetary orbits while still believing the stars sang harmonies unheard by mortal ears. This duality, myth and math intertwined, shows us that science and spirituality weren't always separate paths, but two lenses focusing on the same infinite mystery. Their legacy isn't confined to history books. Walk into any modern observatory, and you'll find echoes of ancient ingenuity. The Babylonians' base 60 system in our clocks and degrees, Chinese supernova records aiding astrophysicists, or indigenous star knowledge reshaping how we approach ecological balance. Even the Hubble telescope's images of nebulas seem to mirror the aboriginal emu in the sky, where cosmic dust tells stories older than writing itself. Yet the most profound lesson lies in their questions, not just their answers. When an Inca priest tracked the Pleiades to predict rains or a Viking navigator steered by the northern lights, they were grappling with the same fundamental awe that drives today's quantum physicists and Mars rover engineers. The cosmos they charted was intimate and immense, a place where comets carried divine messages, but also followed detectable patterns. So as we peer through telescopes or scroll through satellite images, we're part of an unbroken chain of wonder. The stars that inspired ziggurats and stone circles now inspire space stations and quantum theories, but the spark remains the same. Who knows what future generations will see when they look up? Perhaps they'll decode dark matter using tools we can't yet imagine, or find new stories in constellations we thought we knew. One thing's certain, the night sky will never stop whispering its secrets, inviting us to keep listening, keep questioning, and keep reaching. What celestial mystery fascinates you most? Drop your thoughts below. And if you've enjoyed this journey through time and space, hit subscribe so you won't miss our next adventure into the unknown. Until then, keep looking up. The cosmos has always been our first and greatest teacher, and class is never